Okay, so if you fuse this, okay, so if you fuse it, shh. So if you fuse petunia A and petunia B, okay, this has things which make it resistant to actinomycin, okay. Just imagine that these are certain things, certain enzymes or chemicals. So what you did is you fused, okay, you fused them, okay, the fusion is happening, and then you got this newly fused cell, okay, the fused nuclei, the nuclei also they have fused, and then something which helped petunia B become resistant to actinomycin was also gotten into the hybrid. Okay, so then if you grow this hybrid, okay, if you grew this hybrid, no, you grow the hybrid, this is the hybrid, this is petunia B and this is petunia A, okay, you grow this, all three of them you grow into this medium with actinomycin D, okay. What happens? A will not be able to grow, it will be eliminated, so only B and the hybrid is left. Then again you just select from this two only that are still left, so easily you can grow and observe which is the hybrid and which is the B, okay. Okay, so reading here, when you fuse them, they will get both the characters of both the special characters of both the type of species A and B, okay, and they will be resistant to actinomycin D on the medium, okay. So now you can see, it will help you in the selection of the hybrids, because why? Okay, now you must be thinking, but miss, what about petunia B? Okay, the thing is, this hybrid, no, when it grows, it will produce big colony, okay. The cell itself, the callus itself look different, okay, but this petunia hybrid, it forms small colony, okay. Okay, let me start. So this is A, okay, this is A, this is B, and this one is hybrid, okay. So A, it could not grow, forget it, could not grow. B, this all has actinomycin B, sorry, what B? D, okay. B, it grew, but the callus form is small, but the hybrid, it just by observing only, the callus is big, so then you can differentiate from the hybrid and the other one. So this one is just an explanation of what I drew in a simple way, okay. Then looking at the next step, which is auxotrophic mutants. Auxotrophs, they are mutants which cannot grow on a minimal medium, and therefore they require specific compounds to be added to the medium, okay. Means these are not like normal plants, okay, that you just give them food, sugar, they can grow. This one, they need something extra, okay. The thing is, they cannot grow the normal nitrate reductase deficient mutants of tobacco, okay. So these are the mutants which are deficient in this nitrate reductase, okay. So they cannot grow if only nitrate is there in the medium as a source of nitrogen, but the hybrids, they can grow, okay. Okay, so in the medium you have nitrate, okay. Then these are the normal mutants and they could not grow, but you grow the same in the nitrate medium, these mutants, they can grow nicely, okay, they can grow nicely because they are not deficient in this, they don't have the deficiency, okay, they are not sick in this manner, okay. They are they have this enzyme that can reduce the nitrate, okay. It is because of the lack of an apoenzyme, okay, and the other due to a lack of a molybdenum cofactor. So these are why they cannot grow, okay. So again, here this is the diagram, Okay, this species, oh, wow, how did I do that? Forget it. This species is deficient in this, in the cofactor. This species is deficient in this, what to say, apoenzyme. Fine. On fusion of these, okay, both of these are abnormal. Okay, they cannot grow in the nitrate only source. Okay, but if you fuse them, all right, here this one is deficient in NIA, right? This one is not deficient in NIA. Let me explain again. Okay, this one is deficient in this thing. This one's deficient in this thing, but it has NIA plus. This one is deficient in this, but it is abundant in that. This one is deficient in this, but it is abundant in CNX plus. Plus means it has lots. Minus means it has deficiency. Okay. Then what you did, you fused them. So the deficiency of both is removed, right? Because this one you fused this, it was deficient in that, it got from here. This one is deficient in this, it got from there. Okay. This one is deficiency in CNX. You fuse this, it got CNX from here. Okay, from species A. And then species A is deficient in NIA. You fuse and you get the CNX from NIA from species B. Okay, there's no other way for me to explain it. Okay. So there you get the hybrids. It's easy enough. I don't think it's that tough. So you grew them on the medium and they can grow, because only those hybrid can grow, no? Because they got the normal enzyme from their other parent, okay, donor parent. Okay, it is like this is Miss Dihun, no? She's short. Okay, this one is Miss Amy. She is tall. Okay. So if we fuse this one, I have something that makes me tall. Okay, plus T. And Dihun has what? Okay, Miss Dihun has curly hair. Okay, I'll give her C plus. I want curly hair. Okay, and Miss Dihun wants to be tall. So we fuse our protoplast. Then you will get a Miss Teo who has both curly hair and she is more or less tall. Okay, you get it? I am donating the tall gene and Miss D is donating the curly hair gene. Okay, so that is, I think, easy enough to understand. Fine. Now, using the visual methods of selection, this is a very long process. You have to strain your eyes. Okay, but for those of you who are very OCD, you know that nothing beats your own eyes. I am not OCD. I don't really care. You do whatever. I'm like that. But for those of you who are super OCD, unless you straighten your room by yourself, you're not satisfied, right? Like that, okay? So you have to identify the types, okay, the heterokaryons under the microscope, okay? The heterokaryon should be big and green and the parental are small or colorless, okay? So there are two approaches to grow on the solid medium and mechanical isolation, okay? So you select using your eyes, but you have to grow on a differential growth medium, okay? So what this means is that these hybrids, they are sensitive. These protoplast hybrids, they are sensitive to different concentration of media. Okay, like I will take suppose tea with milk. Okay, Miss Dihun will take tea with sugar. Okay, then Miss Rimaya will take tea without sugar. Okay, so we prefer our own drinks, our own food with different. Okay, if Miss Rimaya even gets one drop of sugar, she will not like the tea. You understand? So they are highly sensitive to the growth of the media. Okay. Some media can selectively support the development of hybrids, but not the parents. Okay. So let's look at the diagram. Okay, so you got the hybrid, fine, but you culture it on the selected media. Selected media means you change the concentration of this and that. Okay, you change the concentration of the media. So you give, so this one, so you make tea with milk. Okay, you make tea with milk. So tea with milk, remember it was Miss D Hun's specialty, right? Miss D's specialty. So Miss D, she will like the tea. Miss Rimeya, she won't like, and Miss Amy, she won't like. You understand? So that is what it means by selective media. Okay, doing the mechanical isolation method, it involves you have to use a special pipette. Okay, remember this one is a pipette, no, with a pump. Okay, you have to pull in the media and release, no. This mechanical isolation, it involves a special pipette, okay, known as Drummond pipette. Okay, so the only way is for you to Google it if you're interested. If not, you just remember that part. It's more than enough. Okay. So it means this pipette is designed specifically only to allow the hybrid to pass, and it will not allow the parent protoplast to pass. Okay. Then cytometric method. Oh. Okay, they use flow cytometry and fluorescent activated cell sorting techniques for the analysis of plant protoplasts while their viability is maintained. Okay, so this one, flow cytometry and fluorescent activated cell, it means that you use a dye, okay, DYE, a dye which is fluorescent, okay. But this one doesn't mean you can look in your own naked eyes. You have to look in a sort of fluorescent microscope, okay. This fluorescent microscope will take photographs, and only those okay, suppose this is species A. I give fluorescent dye blue, okay. Here fluorescent dye red, okay. Then if the protoplast is fused, you will get red and blue if we combine. Okay, red and white, okay. This one I gave the dye red, and this one I give the dye white, so I should get a dye which is pink, okay. So when you observe in the fluorescent microscope, no, if the color shows pink, you know that that is the right cell, so you collect that. If you see the cell is red or is white, you ignore those, okay. Okay, let's go to the next. I think I better stop and make another video.